Okay, this is topic 2, water supply systems for an introduction to environmental engineering. So by definition of environmental engineering, by ASC definition, this topic falls under definition number 1 because definition number 1 says that the provision of supplying the safe, palatable, and ample drinking water to the consumers. So that's the one of them. Okay, so here is the overview of this topic. This topic basically is a learning outcome number 1, course learning outcome number 1. Course, uh, course learning outcome number 1 has 2 sections. If I read it, interpret the federal, state environmental regulations and standard and solve environmental engineering problems using energy equation. Mass balance is a topic 1, so energy equation is this one, right? So that's what this will cover. So here are the outline, excuse me, topic outline. We'll discuss a little bit about water cycle, then watershed, water supply systems, then we'll see what are the objectives of this system, then elements of water supply systems. There are 4 elements: source of supply, collection system, treatment system, and distribution system. Finally, we'll see the planning of water supply system, how to plan the water supply system. So the learning objectives for this topic that will transpire to the course learning outcome. So here, define and describe water cycle and watershed. Define public water system, wholesome water and potable water. Describe the basic elements of water supply system and the main sources of water supply. Interpret the water collection system, basics of water treatment and distribution systems. Design the overhead storage tanks. Estimate the pressure at different parts in the distribution system using energy equations. So these are the learning outcomes for this topic. Water cycle. All of us, we know that we have a water cycle in the universe, in the atmosphere, that works for us. So out of this, about 97% of the water on the earth is salt water and in the ocean. Okay, of the 3% of the water that is fresh water, 2% is frozen in the ice caps and only 1% is usable for us. So only the 1% usable water that we have, we use it. Organisms means water vapor found in the lakes, rivers, streams, ponds, in the groundwater, and as vapor in the atmosphere. These are the status of those water. So here this one shows the water cycle a little bit. So water is going up, coming down, right? Is a rainfall going up? Is a evaporation and other things? So it looks like a water strength storage in the ice and snow, different areas and other things like that. So this basically shows a pictorial view of how the water cycle works. Okay, so there are 6 major processes in the water cycle. One is the precipitation. Okay, one is the precipitation. So water from the clouds fall to earth, rain, snow, hail, or sleet. Then surface runoff, the excess water that flows to the land after percolating into the like say soil. And infiltration, rainwater soaks into the ground. The part that soaks into the ground is called infiltration. Evaporation, liquid water changes to a gaseous state as a water vapor. We know that. Transpiration, the water that has been absorbed by the plants will evaporate through the leaves. And condensation, water vapor is changed into a liquid water vapors, join dust particles to form clouds. So these are the 6 major processes that occurs in the water cycle system. Then the watershed, a watershed or drainage basin is an area of land where water from rain or melting snow or ice drains downhill into a body of water, such as river, lake, reservoir, and wetland. So, so this line, it shows the divide, this line, dotted line, and this is a ridge. Means if the water falls here, it will go this way. Water falls here, it will come that way. Here is the one going. So this is called watershed divide. Okay, so that's how we define the watershed. Watershed is very important to know because of if something we take something from one watershed and this watershed, the area it has, there is a lot of pollution and other things, then we'll get a lot of polluted water. So, watershed surface water management plans are implemented to reduce flooding, improve water quality. So this is the main thing, the water quality, enhance stream and wetland habitat. So these are the major things like that. So land usage and water treatment methods are important in maintaining water quality, definitely. Source of water pollution may include point source that we will discuss more in the future, clearly identified, and the non-point source that comes from many different places. Okay, so sources of pollution usually fall into four main categories: industrial, residential, commercial, and environmental. So these are the types of pollution. May include organic pollution, okay, decomposition of living organism and their byproducts in organic pollution, dissolved and suspended solid as silt, salts, and minerals. Toxic pollution, heavy metals, this would be metal. So heavy metals and other commercial compounds that are lethal to organisms. Thermal pollution, waste heat from industrial and power generation processes. Safe Drinking Water Act. This picture is nothing but showing a like say pictorial view, ideal pictorial view, how we can protect the America's public health. Okay, that means this shows like these are the areas, these are the surface water, and you see this is a dam here. So this is upstream, this is downstream. So depending on what we are discharging here and how where we can get the water from to get to the treatment plant and other things. This shows a kind of ideal picture of that. Our real life is not that ideal. So a water supply system, the broad objectives underlying any water systems are to supply safe and wholesome water. Here is a new definition. We'll see how to define it. To supply water in adequate quantity, okay, and to make the water easily available to consumers so as to encourage personal and household cleanliness. So wholesome water defined as the water is unpolluted, free from toxic substances as well as excessive amounts of minerals, organic matter that may impair the water quality. Whereas palatable means like it doesn't have any apparent color or anything like that. So this is palatable. Wholesome, a little bit different. And safe means it doesn't have any pathogens. That means it will not kill us if we drink the water. Okay, so elements of water supply system. In order to design a water supply system, we have to know a few things. Number one is the source, where we can get the water from. Number, how we can get the water from, and then we have to treat it before we supply it to the. Then we have to have a distribution system to supply it to the individual houses through the distribution system. So that's why there are four major elements of that: the supply, collection system, and the treatment system, distribution system. So this is a river, looks like. This is one of our source. Okay, so collection system looks like it can have a collection system, could be something like that. Okay, then this is the treatment part of it, and this is the distribution system. So these are the four different elements that we can show in the picture like that. Okay, so then we'll have a discussion about each of them a little bit. So all water come from the precipitation, in the form of precipitation, whether it is evaporated or some other ways, things like that. As a water falls into the form of rain, snow, sleet, or hail, it acts as a vacuum cleaner, picking up a lot of dust from there. When water hits the ground, a portion of it runs across from the surface ground, and portion sinks into the ground, right? So that means this is infiltration, and this is the surface flow. We know that, we have seen it before, right? So therefore there are major sources of supply are two types. One is surface water supply, other one is groundwater supply. Third one is a minor rainwater, depending on how much rainwater we can get in an area. So we should be able to use it a little bit, whatever the reason we use it. Certain cases they use the rooftop, collect it, and maybe use the water for watering the lawn, gardening, and other things. Sometimes again you can use it for the toilet if you have an option to do that. So surface water supply, mainly the water running across the surface, we call it runoff. It picks up many things, that means it's become kind of polluted in there, right? So surface water. So surface water mainly usually obtained from the streams, rivers, lakes, ponds, reservoir, irrigation canals, and oceans. Since surface water is very likely to be polluted, it needs extensive treatment. So it needs kind of extensive treatment. Okay, then second one is the groundwater supply. The surface water which seeps into the ground is designed as the groundwater or subsurface water, right? It travels through the surface layer of the earth and picks up some minerals and a few organic solution. The microorganism, particulate matter find themselves being kind of filtered out, right? So that means the groundwater taken from the deep aquifers are free from microorganism, could be relatively low concentration of minerals and organic contents. So spring wells, infiltration galleries are the form of cheap groundwater supply. Since groundwater is unlikely to be polluted, it needs a little bit of less treatment compared to the surface water. Then we need to know the quantity. We have to have enough quantity so that we can supply the water for a certain areas or something like that for 20 to 25 years. It could be even more. Sometimes we design it for 40, 50 years. So in terms of the groundwater sources, the quantity of water is available usually less than in case of surface water. This is obvious. But again, in the groundwater, we can run different models to find the amount of water available. So hydrological study, may be performed to find the available groundwater to withdraw from an aquifer. The groundwater supplies withdrawn from a deep aquifer are more constant in their yield and hence more reliable. So, but the issue is if you go to the deep aquifer, you have to dig more, then you have to spend more money to install the what is called the T-wall, right? Quality is very important. There are two different types of impurities in the water. One is suspended, other one is dissolved. So surface water is characterized by suspended impurities because of a lot of things are coming in, and whereas groundwater are by suspended materials because it contains a large amount of dissolved impurities which they gather during travel in the underground strata comprising rocks and minerals. The suspended water often contains the pathogenic bacteria. As a result, surface water are not considered to be safe for drinking without any form of treatment, whereas groundwater are comparatively safer and fit for drinking purpose with a minor or sometimes no treatment. So only treatment most of the time if you have a what is called the hardness, then we have to remove the hardness before you can provide it to the individual houses and other things like that. Okay. So then the choice, how we can choose a source of supply. There are a few things we have to consider. First thing is the location, quantity, quality, and the entire cost of the entire scheme. The quantities definitely should be sufficient for certain areas for the purpose of domestic service, industrial demand, fire, school, hospitals, and other public usage. The quantity of water supply should also include design requirements, which means the calculated quantity would be somewhat higher than the bare needs. Whatever we need, we have to have a more than that, just for the purpose of safety factor. Okay, so and also the quality of water available should be wholesome. We defined it here, safe and free from pollutant of any kind. The health of the public should in no way be endangered due to any situation or anything like that. The quantity, quality of water are the prime consideration in selection of source. So we have to remember that part, right? Cost consideration regarding the development of operation of water supply are also significant. The water from source can be collected to the treatment plant by gravity or by pumping, depending on how where is the source is. If the source is higher elevation, then where we are getting the water to, then definitely gravity is possible. Otherwise, only possibility is the pumping. Okay, the cost would naturally be less for gravity, and the cost would be depend on distance between the source and the distribution system. The cost should be reasonable and be repaid at the end of the design period, which is usually 20 to 30 years. So that means that for the purpose of the business, we have to recoup the money in number of years. That means whatever the number of years we have. Okay, the collection system. Let's finish this one here, and we'll start from the other